Hi, Grade 7. Welcome to Ms. Mice's Math Virtual Classroom. Today, we will discuss about rational numbers. When you add, subtract, or multiply integers, the result is always another integer. Study the following examples. Addition. Negative 7 plus negative 5 is negative 12. Negative 10 plus 3 is negative 7. 9 plus negative 3 is 6. Is the sum of two integers always an integer? So the sum are, so we have negative 12, negative 7, and 6. So it is yes. For subtraction, 5 minus negative 4 is 9. 7 minus 15 is negative 8. Negative 4 minus negative 7 is 3. Is the difference of two integers always an integer? So yes. For multiplication, 7 times negative 3 is negative 21. Negative 6 times negative 4 is 24. 4 times 12 is 48. Is the product of two integers always an integer? So it is also yes. How about for division? 12 divided by 4 is 3. Negative 24 over 3 is negative 8. Negative 20 divided by negative 10 is 2. 4 divided by 12 is 1/3. 15 over 20 is 3/4. Is the quotient of two integers always an integer? So for the first three answers, so 3, negative 8, and 2, so the quotient are integers. But for 1/3 and 3 over 4, so the quotient is a fraction. So the answer here is no. So for integers, so it is just close under addition, subtraction, and multiplication. But for division, it is not always an integer. So the answer is not always an integer. So that is why we have the rational numbers. A rational number is any number that can be written in the form a over b, where a and b are integers, and where b is the integer in the denominator is not equal to 0. The set of rational numbers is represented by a over b, such that a and b are integers and b is not equal to 0. A number of the form a over b means a divided by b, where a is the numerator and b is the denominator. Also, if a and b are both positive, a over b is called a proper fraction if a is less than b. Example, 2 over 5. An improper fraction if a is greater than b. Example, 7 over 3. A whole number if b divides exactly a. Example, 15 over 3 is 5. Write each as decimal. Number 1, negative 7 over 8. So to change decimal, fraction to decimal, so we will divide the numerator by the denominator. So we will just consider first 7 over 8. So 7 divided by 8. So we cannot divide, so we will add 0. So we will take it as 70 divided by 8. So which is 8. Then multiply 8 times 8, 64. So again, we will treat it as 70. So minus 64, which is 6. So add another 0, bring down 0, so 60 divided by 8, 7. Then 7 times 8, 56. Subtract. So it is 4. Another 0. So bring down 0. 40 divided by 8 is 5. Then multiply. So 5 times 8, 40. Then subtract. So 0 is the remainder. So therefore, then we will now affix negative sign. So negative 7 over 8 is equal to negative 0.875. Another. So 2 and 3 over 20. So there are two ways to answer it. So from mixed number or mixed fraction, we will change it to improper. So 20 times 2, 40 plus 3, 43. Over the denominator 20. So 43 divided by 20. So there are 2. So 2 times 20, 40. Then subtract. So 3. So we will add 0. Bring down 0. 30 divided by 20, 1. So multiply. 1 times 20, 20. Subtract. 10. So add another 0. So 100 divided by 20 is 5. Then multiply. So 5 times 20, 100. Then remainder 0. So the answer is 2.15. Another way is, so we will treat 2 and 3 over 20 as 2 plus 3 over 20. So we will just simplify or express 3 over 20 as decimal. So 3 divided by 20. So we cannot divide, so we will add 0. So we will treat it as 30 divided by 20, so 1. So multiply, so 1 times 20, 20, then subtract. Treat it as 30 minus 20, so 10. Add another 0. So bring down 0. 100 divided by 20, 5. 5 times 20, 100. Then subtract, remainder 0. So we will now add 2 plus 0.15 is 2.15. So the same answer. Therefore, 2 and 3 over 20 is 2.15. Okay. So 0.875 and 2.15 are terminating decimal. A terminating decimal is the exact representation of a fraction. That is, a terminating decimal is the quotient obtained by dividing the numerator of a fraction by the denominator with a remainder 0. So you have a last digit, or it ends. Write each as decimal. So this time, so we have number 3, 1/3. So it is 1 divided by 3. Numerator divided by the denominator, so we will add 0. So 10, we will treat it as 10 divided by 3, so it is 3. Multiply 9. So subtract 10 minus 9, 1. Add 1, 0. Bring down. So 10 divided by 3, 3. Then multiply 9. Subtract again. So 1. Another 0. So 10 again divided by 3. So as you can see, so we are just repeating the process. So it seems like it doesn't end. And so on. So meaning, so it is a repeating decimal. So 1/3, so is 0.33333, or we can rewrite it as 0.3 with bar above 3. So, this is an example of a repeating decimal. So, a repeating decimal is a decimal that has a digit or a block of digits that repeat over and over and over and over again without ever ending. So we have the ellipsis and this bar to indicate that we have a repeated. So there is a digit that is being repeated. So every rational number can be represented by either a terminating decimal or a repeating decimal. Okay? That is all for today. And thank you.